Good morning, Mr. Phillips here, and I am so excited to review with you today. So the plan for this is that you will have a piece of paper. You can technically use a whiteboard if you wanted to, if you had your own whiteboard. You could use your iPad screen if you want to go back and forth on Notability or something like that. That's okay. But what you're going to do is you're going to watch the problem, and then you're going to pause the video, work the problem out, all right, see if you can get it right without any help, and then watch the answer, and I'll go through it. So by the time you do 5 of these problems here, it'll take about a half an hour, and I'm really excited to get this going here and to see if you can review well and do a good job with these questions. So problem number 1, here we go. All right, first problem here, we have 4x minus 5y minus the opposite of 2x plus 12y. I want you to go ahead and combine like terms and give your best effort on this question and see if you can show your steps and get the correct answer. So the first thing here you want to do is change all your subtraction to add in the opposite. I still think I'm going to stand by that. That's the easiest way to do these problems. So we have 4x plus the opposite of 5y. Okay, add the opposite here. The opposite of 2x, which is kind of confusing to say, would be plus 2x plus 12y. Okay, so then next we're going to go ahead and find things that are alike. So the 4x and the opposite of 2x plus 2x, equals 6x. And then bring everything else down. Man, I'm on a roll here of making mistakes. You know what? That's okay. You're going to make some mistakes too, and it's not a big deal. Okay, so now we're going to combine the y's. So we have different signs subtract, take the sign of the higher number. In this case, the 12 minus 5 is 7. Take the sign of the higher number. The higher number here is positive, so it'll be a positive 7y plus 6x. And those cannot be combined. X's and y's are different. And so that is your final answer, 6x plus 7y. Okay, very similar question to the last one, although we have to use a property to solve this one correctly. A property is a hint. So go ahead and pause the video and give this one a try. You're going to combine like terms as much as possible. And good luck. Okay, so I'm going to first and foremost change my subtraction to add in the opposite. Before I even start, you're probably tired of me saying that by now, but it makes it so much easier. So the opposite of 14 is literally the opposite of 14, or in this case, negative 14. Okay, the property we're going to use is the distributive property. So we're going to distribute the 9 to both of these. So we're going to give a 9 to the 8x, and we're going to give a 9 to the 12. And I'm going to bring down my negative 14. Now, why do I not give a 9 to the negative 14? Because the negative 14 is not in the classroom. Remember, if we're going to distribute candy to everybody, we're not going to go to the hallway and give candy to this dude. Okay? So, makes no sense. All right. Next, we're going to go ahead and follow the order of operations. And you guys can't really see it right now, but Aunt Sally is staring at my soul. So, we do 9 times 8x, which is 72x. Now, even though those are not like terms, that's basically saying 9 groups of 8x. So that'd be like telling you 8x plus 8x plus 8x. Yeah, I'm going to do it. Plus 8x plus 8x. 1, 2, 3, 4, 5. Plus 8x, 6. Plus 8x. I'm too far. I can't stop. Plus 8x. 1, 2, 3, 4, 5, 6, 7, 8. Plus 8x. It'd be the same thing. Okay? I did that for all those students that are annoyed by that. So my apologies, but you guys are used to it by now, right? Okay, so now give me a time to erase this. I'm sure there's a faster way to erase. Leave a comment below if you know how to erase faster. Okay, we're going to go ahead and do 9 times 12, which is 9 groups of 12, which would be, in my head, 108. Okay, now, ironically, real quick, I did the distributive property to solve that one in my head, which is pretty cool. So in my head, I did this problem, which is 9 times 12, and I took 9 times 10, which is 90, and then 9 times 2, which is 18, and I added those together and got 108. So cool hack there is I use the distributive property to do that mental math. Okay, now we're going to bring down the negative 14. Okay, so our like terms right now are these. Oopsies. I'm having some issues with my Apple Pencil today. That's okay. Okay, different signs subtract. We're going to do 108 minus 14. Now I'm going to be careful here. This is the one I'm going to go ahead and work out. We get 94, okay? And that's going to be a positive 94 because we take the sign of the higher number, and that's 108. So we have 72x. You can tell that Bobby and Joe and I are related. Every now and then his voice comes out. Okay, 72x plus 94. Those are not like terms. So that is your combined final answer. So this is what kind of makes math fun. I have an equation here that I literally just made up on the spot. So I don't know the answer yet. My assumption is this going to be a fraction or a decimal, but we'll find out here soon. So go ahead and pause the video and solve for x. Objective here with this is to isolate the x and to figure out what it equals. But before we do that, we're always going to change our subtraction to add in the opposite. So we have 5x plus negative 12. Keep in mind, the opposite of 12 is negative 12. And that was a minus earlier. Okay. Then we have 10 plus the opposite of 7x, which is adding the opposite here also. Okay, so our first objective is to pick something to get rid of or to move over to one side or the other. So what I'm going to do here first is I'm going to get the 7x over with the other x. I'm going to add 7x to both sides. These are very similar to the pawns that we used earlier in the year. This is a pair of zeros, so we're going to yeet that. And so we have 12x plus negative 12 equals 10. Okay, now my one concern with getting rid of the 10 right now would be if I take this 10 and move it over here, then I have nothing left on this side over here. So I want to make sure I am not getting rid of everything on one side of the scale. So instead, I'm going to move the 12 over. So I'm going to add 12 to both sides, turn that into a pair of 0. So yeet that. 12x equals 22. Okay, now we're going to go a little bit further with this, and we want to turn this 12 into a 1. So we're going to divide both sides by 12. So we have 12 over 12x, which equals 1x, and now the x is isolated. Remember, 1x and x are the same thing. So we have isolated the x. Now this right here is some basic, can we do some division? So 12 goes into 22 one time, and we have 10 left over. So our initial answer is 1 and 10/12. Okay, but I'm going to go ahead and simplify that a little bit. So my final answer for this one is 1, and then 2 goes into this 5 times, and 2 goes into this 6 times. So my final answer is 1 and 5/6. That's how you delete. Okay, and we're back. Whew. So we're going to find the area of this trapezoid. Now you need the formula for area. It's 1/2 times the height times base 1 plus base 2. So true story, while I'm drawing this, my dad just the other day said that he used this formula when he was roofing, and it's pretty cool to hear that this is used in the real world. So I'm not going to include labels. When you do this here, let's just say we're doing units, okay? Okay, there's our numbers, and I will give you a hint. You do not need all of them. Find the area of that trapezoid using the formula over here. Okay, so I'm going to go ahead and plug in my numbers, and with my formula, I have the height, which is always perpendicular to the base, so this would be 9. And then base 1 and base 2 are always parallel. So that would be 10 and 12, we do not need the number 11. So I'm just going to ignore the number 11. I don't need that one. Okay, following Aunt Sally's rules, I have to do parentheses first. So I have 1/2 times 9 times 22. And then what I'm going to do here is do half of 22 first, which is really easy. So I have 11 times 9. And then my final answer, which makes this super easy, is 99. Now, this would be area, so I'm just going to say units squared for my answer for area. So the area of the trapezoid is 99 units squared. Okay, right before break, we practiced the rules of 10%. And I like 10% because 10% essentially is the same as 1/10. And then the word of is always translated in math, usually always, not always, but most cases we translate it to groups of, which is the same as multiplication. And then we have 40. So if I was going to say this in a math sentence, I could say, what is 1/10 groups of 40? Which I know is kind of a weird comment, but it should make sense. And the cool thing about 10, which is the reason why most countries have the metric system, is it moves the decimal. So our decimal right here, if we divide by 10, it just moves it one place to the left. So 10% of 40 equals 4. Okay, so I'm going to give you a variety of questions and then see if you guys can figure it out using some mental math. All right, so here we go. Ah. All right, here's your questions. What's 10% of 83, 40% of 90, 60% of 70, 85% of 20, and 1% of 50? So go ahead and pause the video, try to figure all these out in your head, and then I'll go through the answers here shortly. Okie dokie. We're going to go ahead and do the first one. 10% of 83 is going to shift the decimal over one place, so that would be 8.3. Okay, 40% of 90. We have to start off with 10%. So 10% of 90, and I'll put a little note over here, is 9. So 40% would be 9 times 4, which is 36. Okay, we have 60% of 70. So we start off with 10%. 10% is 7. So 6 times 7 is 42. So 60% of 70 is 42. 85% of 20 is a little bit tricky. Now, technically, we're actually using the distributive property here. We're trying to figure out 80% and 5%, and then we're going to add them together. So I'll just write off the side. 80% of 20 is 16 because 10% is 2. So 8 times 2 is 16. All right. 5% is actually 1 because 10% is 2. 5% is half of that. So we just do 16 plus 1 with the distributive property, and that would be 17. So 85% of 20 is 17. Okay, 1% of 50. Now, 1% is the same as 1 out of 100. So if you think about it, you're going to move the decimal place not only over once, but we're going to move it over twice per 100. So 1% of $50 would be 50 cents. Okay, we're going to kind of build on those percent ideas throughout the rest of the semester. So that's what the last problem for the day. Hopefully you got them all right. Great job on the video.